Hi everyone, I'm Shubham Jhanwar. We are discussing KVPY 2017 SX, and the question for this video is this. Let Z1, Z2, Z3, so on and so forth up till Z7 be the vertices of a regular heptagon that is inscribed in the unit circle with center at the origin in the complex plane. Let W is equal to sigma Zi Zj, where I is greater than equal to 1, less than j, less than equal to 7. Then mod of W is equal to. So here, since the answer is supposed to be something certain, not depending on what exact regular heptagon we are talking about, let's consider Z1 to Z7 to be the seventh roots of unity. That means seventh roots of unity. We'll generalize towards the end. What if you don't take Z1 to Z7 to be seventh roots of unity? We'll generalize at the end, but at this point of time, let's consider Z1 to Z7 to be seventh roots of unity. So I may say, let's say Z1 is 1. If Z2 is alpha, Z3 will be alpha square, Z4 will be alpha cube, Z5 will be alpha to the power 4, Z6 would be alpha to the power 5, Z7 would be alpha to the power 6. Where alpha you may say to be e to the power iota 2 pi by 7. Yeah. So here this thing I may write as what? Sigma Zi I equal to 1 to 7 whole square minus sigma Zi square I equal to 1 to 7 whole divided by 2. It's very simple. Sum of product of two terms taken at a time, where whatever be the number of terms is same as square of sum of those terms minus sum of squares of those terms divided by 2. Yeah. So here sigma I equal to 1 to 7 Zi is essentially sum of seventh roots of unity, which would be 0, which we know is supposed to be 0. Why so? Because it's very simply because z to the power 7 equal to 1 has roots z1, z2, so and so forth up till z7. So you may say z to the power 7 minus 1 equal to 0 has these 7 roots, and the sum of roots is 0. Yeah, so here clearly you can say sigma zi I equal to 1 to 7 is 0. So now what about sigma zi square I equal to 1 to 7? So what is sigma zi square? Yeah, I equal to 1 to 7. It is essentially 1 square plus z2 square is alpha square. You get alpha to the power 4 because z3 square will be alpha square whole square, alpha to the power 4 plus alpha to the power 6 plus alpha to the power 8 plus alpha to the power 10 plus alpha to the power 12. Yeah. So here you get 1 plus alpha square plus alpha to the power 4 plus alpha to the power 6. Alpha to the power 8 is essentially alpha only. Why? Because you can clearly see that here product of roots is 1. Yeah, so you may say pi zi is equal to 1, you may say, or rather than that you may just say okay, hey, z1 is a root and z1 is alpha. So clearly alpha to the power 7, a root of this is alpha, which is essentially z1. So you may say alpha to the power 7 minus 1 is 0, or you may say alpha to the power 7 is 1. So if alpha to the power 7 is 1, alpha to the power 8 is alpha. Similarly, alpha to the power 10 is alpha cube, and this is alpha to the power 5. So you have 1 plus alpha square plus alpha cube plus alpha to the power 4 plus alpha to the power 5 plus alpha to the power 6, which again is 0 because it is sum of these seventh roots of unity. Yeah. So this essentially means 0 square minus 0 whole divided by 2, it's 0. So that means mod w is essentially 0. Why? Because w is 0. Yeah. Now what if the regular heptagon is rotated? Yeah, and z1 to z7 are not necessarily the seventh roots of unity. What in that general case? In that general case, if you think all the terms would get multiplied, that means z1, z2, z3 till z7 what we have considered, all of them would be multiplied by, let's say, e to the power iota theta, where theta is any non-variable constant angle. Yeah, because if you rotate the heptagon by angle theta, let's say anti-clockwise or clockwise. In anti-clockwise sense, theta you may say is positive, in clockwise sense it will be negative. So this e to the power iota theta will get multiplied to all these terms. And if you see this expression, that e to the power iota theta will come common here inside the square. Yeah, and the sum of the remaining terms after taking e to the power iota theta common would again be 0, because that would essentially be 1 plus alpha square plus alpha cube plus alpha to the power 4 plus alpha to the power 5 plus alpha to the power 6. Yeah, similarly in the second term, sigma zi square, e to the power iota 2 theta would come common. Yeah, so that essentially would become e to the power iota 2 theta multiplied by the same expression that we have considered, which turns out to be 0. So 0 multiplied by e to the power iota 2 theta would again be 0. So that means it holds for any general regular heptagon inscribed in a unit circle with center at origin in the complex plane. Answer is 0. Thanks for listening.